Today we discuss few more problems on limit and continuity. First problem, the point of discontinuity of the function f(x) is equal to 3 pi by x square into x square plus 1 into limit t tending to 0 tan square tx by t into t square plus 1 into x. The question is, this is a function of x because this is x and there are some t other variable, but t tending to 0, that variable is tending to 0, it is given, so that it would be a function of x only. So ultimately this is a function of x and we have to find out the number of point of discontinuities of that function. Options 0, 1, -1, and last option is continuous everywhere. So I first treat that limit. After treating this limit, it would be a function of x only. So f(x) is equal to 3 pi by x square into x square plus 1 into limit t tends to 0 tan tx whole square by, I write tx whole square. Now we have to adjust it. Tan square tx already taken. Tx is there, but I have taken t square x square. So for adjustment, it is tx by tx t square x square, then at t square plus 1. Now, so t is there, x square, so x is there, and tx by t square plus 1. So okay, so that this is equal to 3 pi by x square into x square plus 1 into, this become 1 into it is t square x square, this tx, t square x square, t, so that t, x is there, okay. So that now it becomes, taking t tending to infinity, 0, so this becomes 0. So this is, I think I have mistaken somewhere. In copying the problem, I think I have mistaken somewhere. Okay, let us drop the problem. আচ্ছা, next problem. If fx is equal to if fx is continuous function satisfying fx into f of 1 by x is equal to fx plus f of 1 by x, and f1 is positive, then the value of limit x tending to 1 fx, how much? Options. Oh, this is 0, 1, 2 and -2, or this is 2. Okay. The problem is that fx is continuous function, continuous everywhere, and a relation between fx and f1 by x is given that f1 is positive. In that case, limit x tending to 1 fx, how much? From there, putting x is equal to 1, this become f1 into f1 is equal to f1 plus f1, so that f1 square is equal to 2f1, and because f1 is positive, so f1 cannot be 0, so that f1 is equal to, taking f1 common, this is f1 minus 2 is equal to 0. So either f1 is 0 but f1 is greater than 0, so only possibility is that f1 is equal to 2. Value of f1 is 2, I obtained, but we have to find the limiting value of x tending to 1 fx is how much. And because the function is continuous everywhere, at x is equal to 1, it is also continuous. So f1 is equal to limit x tending to 1 fx, but f1 is equal to 2, so limit x tending to 1 fx is 2. So this option is correct. Next, take the problem. Find the limit of x tending to 0, 1 to the power x plus 2 to the power x up to n to the power x by n whole to the power 1 by x. Its options are factorial n by 2, factorial n to the power 1 by n, and factorial n divided by e. These are the options. So to solve For this problem, I use that formula, limit x tending to 0, a to the power x minus 1 by x is equal to log a base e. Using this formula, I think we can solve it. For that purpose, this one is equal to limit x tends to 0, it is 1 to the power x minus 1 plus 2 to the power x minus 1 plus n to the power x, this is x, minus 1 divided by n. Actually, I have taken minus 1, actually I have taken minus 1 n times. So minus n I have taken there. So we have to adjust it by plus n whole to the power 1 by x. So that it is equal to limit x tending to 0. This part n by n is 1 plus this one, let us take it is as u. U means how much? The numerator up to that whole to the power 1 by x, where u is equal to 1 to the power x minus 1 plus 2 to the power x minus 1 plus up to n to the power x minus 1 by n. 1 plus u, so this is divided by n. Now this one, that part, limit x tends to 0, it is 1 plus u to the power 1 by u. Now adjust to the power u by x. It is 1 upon x, so u cancels, x is there. Now it is simply equal to e to the power limit x tending to 0 u by x. Now let us see what is x tending to 0 u by x, how much? It is equal to 1 to the power x minus 1 by x plus 2 to the power x minus 1 by x up to n to the power x minus 1, that divided by x whole divided by n. Now limit as later taking ax tending to infinity, this is log 1 base e 0, log 2 base e, log 3 base e, log n base e, so that it is equal to log of 1 into log of 2 base e into log of n base e, all are base e, so divided by n, so that it is equal to log of factorial n 1, this is plus, plus, so log 2 plus log 3 plus log 4, and this is equal to, this is 1 by 1 by n, so that u by x is equal to this one. So it is e to the power 1 by n into log of factorial n, so that it is e to the power log of factorial n whole to the power 1 by n, and e to the power log balances, so answer is factorial n whole to the power 1 by n. This one is correct option. Next, limit x tends to 0 sine of pi cos square x by x square. Options: pi by 2, 1, minus pi, and plus pi. And that problem was given JEE Main in the year 2000. So this is equal to limit x tends to 0 sine of pi into 1 minus sine square x by x square is equal to limit x tends to 0 sine pi minus pi x. So it is equal to sine of pi sine square x by x square, so that it is equal to limit x tends to 0 sine of pi sine square x by pi sine square x into pi to be adjusted pi sine square x by x square. Here also limit x tends to 0. Now considering this limit, x tends to 0 means this tends to 0. So sine of this by that, it is 1 into pi into sine x by x whole square, x tends to 0, 1. So that pi is answer. So this is answer. Next problem. If fx is equal to 1 minus t by 1 plus t, where t is equal to x by x plus 1, then its point of discontinuity is one and half. Means its point of discontinuity is at the point x is equal to 1 and x is equal to half. Next, minus 1, half. Next, minus 1 minus half. Next, 1 minus half. Okay, so actually fx is equal to 1 minus t by 1 plus t. It is not a function of x, but t itself is a function of x. So ultimately, this is a function of x. Putting these values of t over here, 1 minus x by x plus 1 by 1 plus x by x plus 1. So that in denominator, after simplification, x plus 1 will cancel. X plus 1, so 1 upon x will be cancelled, 1 upon 2x plus 1. So that we get fx is equal to this algebraic function and real, but you see it is undefined at when this becomes 0, that is at x is equal to minus half. At the point x is equal to minus half, it is undefined. Again, very important thing, again you see t is undefined at x is equal to minus 1. T is undefined at x is equal to minus 1. So if t is not defined, the function is not undefined. So that the function, point of discontinuity of the function is x is equal to minus 1 and minus half at these 2 points. Minus 1, minus half. So this is correct option. Next. If fx is equal to 3x plus 2, if x is greater than or equal to 1, is equal to 2x if x is less than 1, and gx, another function defined as x plus 1 if is equal to kx if x is less than 1. If phi x, the function fx into gx, is continuous at x is equal to 1, if phi x is continuous at x is equal to 1, then value of k is options 2, 3, 4 and 5. That problem is very simple. Actually phi x is equal to fx into gx. Fx is this defined in 2 intervals, this and that. Gx also defined in same 2 intervals. Therefore, this is equal to 3x plus 2 into x plus 1 if x is greater than or equal to 1 is equal to 2x into kx if x is less than 1. Now, given that phi x is continuous at x is equal to 1, so phi 1 is equal to, phi 1 can be obtained from there, x is equal to 1 is defined here. This is equal to 3 plus 2, that is 5, into 1 plus 1, that is 2. It is equal to 10. Left hand limit of fx phi x, left hand limit at obviously at x is equal to 1. Now left hand limit can be obtained from here, and x is defined here for x is less than 1, so that it is equal to 2 into 1 into k into 1, that is 2k. its right hand limit. Right hand limit means in that case x is greater than 1 can be obtained from this. So it is equal to 3 into 1 plus 2, 1 plus 1, that is 10. So we obtain at that conclusion that phi 1 is equal to 10. Left hand limit at x is equal to 1 is 2k. Right hand limit at x is equal to 1, 10. So as because they're continuous, the function is continuous at x is equal to 1, these three must be same. 10, 10 they are equal. So we must get 2k is equal to 10, that is k is equal to 5. So this option is correct. Next. Takendrapati. Acha, next. The limiting value of x tends to 2, x to the power x minus 4 divided by x log x minus 1, of course base is e. Find its limiting value. The options: log 2 plus 1, log 2 plus 2, 2 log 2 plus 1, and 2 log 2 plus 4. Achha, we know that x can be written as e to the power log x. E to the power log x, e and log balances x, so that x to the power x can be written as e to the power log of x to the power x is equal to that x e to the power x log x. X to the power x is that. So this become limit x tending to 2 e to the power x log x minus 4 divided by x into log of x minus 1. Now by putting x is equal to 2, this is e to the power, but e to the power, actually it is x to the power 2 to the power 2, that is 4. 4 minus 4 is 0. This is 0 and log 1 is 0. So of the type 0 by 0 form, we can apply L'Hospital rule. That is, we have to differentiate numerator and denominator separately. So limit x tends to 2, its derivative e to the power x log x itself into derivative of that, it is 1 into log x plus it is x into 1 by x, that is 1. It is constant 0. Then it is log of x minus 1, derivative of x is 1 plus x into 1 by that. So that it is equal to, putting x is equal to 2, it is actually it is x to the power x. This one is x to the power x. So it is actually 4. It is log 2 plus 1 by, this is 0, log 1 0, by 2 by 1, that is 2. So by putting x is equal to 2 over there, we get result. So it is 4, then log 2 plus 1 by, this is 0, this is 2 by 1, that is 2. So that 2 into log 2 plus 1. Oh, 2 into this 2, okay, 2 into log 2 plus 1. Oh, I think option is this, so that option is correct. Next, the value of f0, so that where fx is equal to 1 minus cos of 1 minus cos x divided by x to the power 4. Given that fx is continuous everywhere, we have to find f0 where fx is equal to that, and given that this is continuous everywhere. Now if this is continuous everywhere, so it is continuous also at x is equal to 0. So in that case, f0 will be equal to limit x tending to 0 fx. That is this. Now at x is equal to 0, you see it is cos 0 means 1. So it is equal to 1 0 by 0 form. So we can apply L'Hospital rule, so that it is equal to limit x tending to 0. Its derivative is sin x, sin not x, sin of that thing, 1 minus cos x, minus cos, its derivative is sin, and its derivative is once again minus, and derivative of cos is minus sin. So this is equal to minus and minus, that is sin x, divided by derivative of the denominator 4x cube. It is equal to limit x tends to 0, sin x by x, I have taken sin x by 1x into limit x tends to 0, sin of 1 minus cos x by 4x square. This is 1. So that it is 1 by 4, this one 1 by 4. Now again we can apply L'Hospital rule, because x tending to 0, this is 0, sin 0 is 0 by 0. So it becomes cos of 1 minus cos x into derivative of that part, minus derivative of cos x is minus sin, so plus sin x by 8x. Limit, of course, limit is there, limit x tending to 0. Now this one, limit x tending to 0, this one is 1. So answer is this. Actually this is equal to x tending to 0 মানে it means it is 1 cos 1 divided by 8. This is 1. So answer is 1 by, option is not, I have not given option. So option is 1 by 8. Next. Fx is equal to integral part of x plus integral part of minus x if x not is equal to 2 is equal to lambda if x is equal to 2. Then, and if fx is continuous at x is equal to 2, then lambda is options -1, 1, 0 and 2. And that problem was given in WB JEE 2011. Actually, I have taken that problem last day, but to drop it or drop that, now you follow this one today. I am doing it properly. You see, integral part of x, it is equal to 0 if x lies between 0 to 1 and equal to 0 also. It is equal to 1 if 1 less than or equal to x less than 2. It is equal to 2 if 2, 3. That part is actually integral part. You can keep in mind in that way that is the lower value of x, lower limit of x, and it is equal to -1 if -1 less than 0. It is equal to -2 if -2 less than -1. It is equal to -3 if -3 less than -2. This is the proper definition of integral part of x. And now simply we apply it. Now, given that phi fx is continuous at x is equal to 2, then what would be the value of lambda? Its left hand limit at x is equal to 2, left hand limit is equal to, this is x. I am taking x tends to 2, left hand limit means 2 minus say h. 2 minus h, where h is very small quantity, so that it is equal to 2 minus h plus -2 into 2 minus into 2 minus h. 2 minus h, it is less than 2. Less than 2 means in that interval, so it is 1. And it is actually, this is less than 2, -2. It is less than -2. In that case, it is equal to -3. No. Answer is In that case, 2 minus h, it is actually equal to minus 2 plus h. Minus 2 plus h, it lies in that interval. So it is equal to minus 2, minus 1. Right hand limit is equal to, in that case, x can be taken as 2 plus h, so that this become box of 2 plus h plus box of minus 2 plus h. It is more than 2, so that it is just 2 point something. So 2 point something means it is 2, and it is less, it is actually 2 plus h less than that, so that it is equal to minus 3, so that once again it is minus 1. So left hand limit and right hand limit both are minus 1, and as because it is continuous, f of minus 1 is equal to, it must be minus 1, that is lambda must be minus 1. So this is our answer. Thank you.